In today's lesson, we're going to find the area of polygons by decomposing them, taking them apart into different pieces and finding the smaller areas, and then putting them back together to find the whole. Let's take a look at example 1. The intermediate school is producing a play that needs a special stage built. A diagram is shown below, but not to scale, meaning if it's 2 feet, it might not be something that's comparative to that. Okay, so here is the stage, and something that's important, we're going to be finding some unknown measurements, and when we find them, it may not be whatever you get your ruler out and measure, because it's not to scale. Okay, so this is not truly 2 meters, it's just representing 2 meters. Okay, here's what we should do. On the first diagram, this one right here, divide the stage into 3 rectangles using 2 horizontal lines. Find the dimensions of these rectangles and calculate the area of each. Then find the total area of the stage. Okay, so we need to use 2 horizontal lines to make 3 rectangles. Let's see. If I draw a horizontal line right here, I'm going to go ahead and do that. And I draw a horizontal line right here. I've got 2 horizontal lines, and I've got 1, 2, 3 rectangles. I'm going to number them, just so I know which rectangle I'm talking about as I go ahead with my area. Okay, I need to find the area of each one of them, and then I'll find the total area. All right, we need to remember that the area formula, area equals, I guess it's equals, area equals base times height for a rectangle. So let's look at rectangle 1. The base is 2 meters. So here's for 1. We have 2 times the height. Now this one we don't exactly know. It's not giving us the height here, and it's not giving us the height here. But if I was to make that horizontal line all the way across right there, this is the same height as this one. Therefore, I know that if this is 4 meters, this has to also be 4 meters. Okay, so we have 2 meters by 4 meters, so 2 is the base times 4 is the height, equals 8 meters, and because it's area, it's squared. Remember, area always has a square unit. Okay, so the area of rectangle 1 is 8 meters squared. Let's find the area for rectangle 2. It is 2 for the base times 4 for the height. It's also 8 meters squared because they're identical. Okay, for 3, I have a base of 7 for the third rectangle. I have a base of 7 times a height of, well, I can't do 9 because 9 is from all the way down here to all the way up here, and we're only going up to here. So we need to figure out how far this is, and this will give us what's left out of 9. So together, this plus this is 9. Well, I found that this is 4, so this must be 4 meters. The whole thing is 9. If I take that 9 and I take away 4, I'm left with 5 meters. So this is going to be 7 meters times 5 meters equals 35 meters squared. Now, I found each individual rectangle's area. Now we need to find the total area of the stage. So we need to add these together. For this purpose, I'm going to bring out my calculator. This just might be a little bit easier. I know 8 and 8 is 16, so I'm going to add 16 plus 35. And I get 51 meters squared. That is the area of the whole stage here. Okay. Let's take a look at the next example. I'm going to take that out. Okay. On the second diagram, here, it's another one. It's the same stage, same problem. Divide the stage into 3 rectangles using 2 vertical lines. Okay? And then find the dimensions of each and the total of each. Okay. Vertical lines, 2 vertical lines. Ooh, I can do one here. Ooh, and I'm gonna use my paper to make a straight line. Line it up. Make it as straight as I can. 1, 2 vertical lines. Okay. I should probably number those. Let's do the same idea. We'll do 1, 2, 3, like we did before. I have 3 rectangles. Now I need to find the area of each. Remember, area formula is base times height, or BH. And I like to put that always at the top when I'm trying to solve problems so I can plug my numbers in. It'll get a little tricky if I don't. Okay, rectangle 1, base of 2 times a height of 9. It's now the whole thing. 2 times 9 equals 18 meters squared. Okay. 2 is 2 by, well, it's not 4, because that only stops here. We got to go all the way. 2 by 9, because this one is 9 on this side. This side is also the same, because these are the same length here. Okay, so this is 9 meters. Okay, so we have 2 by 9 is equal to the same thing. Again, they're identical. Rectangle 3, this is going to take some math. Okay. Now I want to go from here to here. Well, let's see. I knew last time I kind of did this, where this one was 4, right? And the whole thing was 9, so from here to here was 5 meters. So this must be 5 meters. It's not 5 by 7, because 7 is this whole line. We want just that part in the middle. Oh, that's even trickier. Let's see. Well, this part from here to here is 2 meters. And this part from here to here is 2 meters, because it matches the one above it. So then the whole thing is 7. This takes a lot of dissecting here. We're going to dissect it like in science. Okay, so this whole thing is 7 meters. So if we have 2 and 2, that's 4. 7 minus 4 is 3. So I'm going to take him off it. This is 3 meters. Whew. Okay, so our base is 3 times our height of, oops, 5. I just multiplied in my head, sorry. That equals 15. I was going ahead with my 15. 15 meters squared. That was a lot of steps. A lot of steps. If you're not sure, kind of pause it and talk yourself through it, or maybe rewind and listen again, or write down a question that you have if you're not sure. We still have some more. Let's keep going. Okay, we need to add them all up. I'm going to use my calculator again, my handy dandy calculator. All right, we have 18 plus 18 plus 15. 51 meters squared. Now, that's the same as before, as it should be, because these are the exact same stage. We're just showing 2 different ways of splitting them. Doesn't matter where you split them, you get the same 51 meters squared. Awesome. Okay. Let's try another one. We can split it a different way yet. On the third diagram, divide the stage into 3 rectangles with 1 horizontal line and 1 vertical line. So we need 1 horizontal and 1 vertical. Okay. What if we split horizontal here? Make that 1. And we split vertical here. Let's make this 2. And then we'll make this one 3. We have 3 rectangles. We did a horizontal line and a vertical line. It's another way that we could split this. Okay, Same idea, area equals base times height. So for the first rectangle, we have 2 by, we said that this was 4, because that's 4. So 2 by 4 equals 8 meters squared. 2 was 2 by the whole thing, which we said was 9 meters. So we have 2 times 9 is 18 meters squared. Okay, now this one we gotta do some math here. Okay, so I need to know from here to here. Ooh, okay, that's the same as from here to here. We know that's 4. 4 and 5 makes 9, so this is 5 meters. And now I need to know from here to here. Okay, well, let's see. This whole thing is 7. If I know this little part, I could find out the bigger part. That little part is 2 meters. 2 and 5 meters makes 7. Okay, so that means that we need a base of 5 times a height of 5 equals 25 meters squared. Okay, so that's each part. Now we got to find the area of the whole thing. So let's add those areas up. 8 plus 18 plus 25. What should we get? 51? Ta-da! 51 meters squared. Now the purpose of this part, these 3 first examples, are to show you that it doesn't matter how you split it, as long as you split it into rectangles. And if you have 3 rectangles and you add them all together, it will give you the same amount. You could do a horizontal, you could do vertical, or you could do both. I would choose to do the one that would probably be the simplest, not necessarily the one that is going to be the hardest. Whatever one's going to maybe have the most measurements for you and you don't have to figure out others. Sometimes when I see a problem like this, I like to fill in all the missing blanks, so I might fill in this part and this part and that part so that I have all those measurements and I can just do whatever I need to do. There's one more way that you can solve this problem. Okay, so those were the ways you could split it up. This way, we're going to kind of find the whole thing and minus a little bit. So if we continued this across the top here, and we made one large rectangle. So let's say we have this large rectangle right here. We need to find the area of the large rectangle and the area of the small rectangle we've created. Then we can take the large rectangle, we can take out the small rectangle, and we'll be left with our original stage shape. Okay, so let's find the area of the large one first. Remember, area is base times height. Okay, so we'll call the big one number 1 and the small one number 2. How about that? Just to keep that straight like we were. Okay, area of number 1 is going to be a base of 7 times a height of 9 is 63 meters squared. And you're probably saying, wait a minute, but the whole thing was 51. Well, yeah, but now we added this part into it because we're going to find the whole rectangle. I promise it will work. Okay, let's look at just the small rectangle. We need to figure out what the base is. Well, let's see. If it was a full line, it would be the same as 7. But we need to come in 2. Now we're down to 5. We need to come in 2 more, and now we're down to 3. So this is 3 meters. Okay, so we have a base for the small one of 3 times a height of 4 is 12 meters squared. Okay, now we're taking out the small one, so we need to subtract. Well, I could do that one. I could do that one on paper. 3 minus 2 is 1. 6 minus 1 is 5. Still 51 meters squared. Okay, let's look at another problem, shall we? On this one, we've been dividing up and finding the area of rectangles. We are going to now find the area of a parallelogram. This is going to be a little bit trickier. All right, it says parallelogram A, B, C, D, named by its points, its corners, is part of a large solar power experiment. The base measures 6 meters and the height is 4 meters. Now they'll draw it over to the side just to show you how tall it is from the bottom to the top. So anywhere inside here is 4 meters. Okay? It would like us to draw a diagonal from A to C. I'm going to use the edge of my paper here to go from A to C. Like a little straight edge, like a ruler. I'm going to draw my diagonal from A to C. Okay? Find the area of both triangles ABC, so this triangle right here, and triangle ACD, ACD. So we're going to find the area of each of those triangles. If you remember the area formula for a triangle, I'm going to put this information down here actually. So the area formula for a triangle is 1/2 base times height. Okay, because it's half of a rectangle. All right, so let's do ABC first. So we're going to triangle ABC. And we're going to do area equals 1/2 the base of 6 times the height of 4. All right, there's a couple ways we could do this. We could do 6 times 4 and then find half of it. Or we could find half of 6 and then multiply by 4. Or half of 4 and multiply by 6. I would like to do this part first. Let's do half of 6 is 3. 3 multiplying down by times 4. 3 times 4 is 12 meters. It's area, so it's squared. That's for this one right here. Okay, let's do triangle ACD. Okay, area equals 1/2 times the base. The base is the bottom, which is going to be here if we turned it around, which is 6, times the height, which is 4. We know that answer because we already solved it, is 12 meters squared. Now that's for each part. Now we need to add those together to give us the area of the entire parallelogram, which is 24 meters squared. Now, a parallelogram is just a rectangle that's kind of crooked, kind of tilted. It's got the same idea for formula. We can split it. We could also use the same formula as a rectangle and do base times height. 6 times 4 is 24. Either way, if you don't remember the formula for a parallelogram, break it into triangles and find the area of both triangles. All right. We could also, sorry, I was going to tell you one more thing. If we split it this way, ignore my crazy line. If we split it this way instead, it would be exactly the same thing. So it doesn't matter which angle you split it on, as long as you split it on an angle to make triangles. All right. One more example. Let's find the area of a trapezoid. All right. The trapezoid below is a scale drawing of a garden plot. Okay, so it's a scale drawing, so it looks like kind of what it would be. This is trapezoid ABCD, named by its points, or its corners. It says find the area of both triangles ABC and ACD. I don't see triangles. I think we should create them. So we need a triangle ABC. So I would need a line right here, kind of like we did with the parallelogram. Okay, ABC, there's my triangle, and ACD. Ah, yes, 2 triangles. Okay, we can do this. Let's do this. Okay, So we need triangle, let's do the area first. Area is 1/2 base times height for a triangle. So area, let's do triangle ABC first. Area equals 1/2 of the base, which is 8, times the height of 5. All right, so half of 8 is 4. So let's do 4 times 5. The area is 20 meters squared. Okay, let's find the area of triangle ACD. Area equals 1/2 times the base, and our base is smaller on this one, so our base is 4 times our height of 5. Okay, so 1/2 of 4 is 2 times 5 is 10 meters squared. That's our two triangles that we created. We put them together and they'll create the trapezoid, so 20 and 10 makes, I'll put down here, 30 meters squared. Together those make 30 meters squared. So today's lesson is all about decomposing, like breaking them into different shapes. We broke some into rectangles and some into triangles. And so we really only need 2 formulas to find the area for polygons. So just break it into shapes that you know how to find the area of, find the area, and put it all together. Any questions? You know the drill.